Good morning, everybody. This is Mr. Chestnut. I hope everybody's having a fine and pleasant day. Can I get a whoop whoop from you? Today, I want to remind you that we are going to have our unit test. I've decided to have the unit test on Thursday. Today is Tuesday, December 15th. On Thursday, December 17th, we're going to run this test. Yesterday, I started to review the multiple choice questions. You can continue to study those. Today I will step back once again and go into the word problems that are going to be found on the test, and we are going to start to prepare you for those. Please make sure that you mark your attendance in Teams. If you have any questions throughout the day, feel free to reach out to me through Teams. I'm here to help you. All right. That being said, today what we're going to do is we're going to look at a stationary 45 kilogram object, which is sitting on a table near the surface of the earth. So if we do a quick little sketch of this, we take a look at this right here, we can see what we have is we have a object that's on a surface here. Okay, it has mass, which is 45. It's being pulled with a force of 600, and the coefficient of friction is equal to zero point 0.2. The first step is to draw the free body diagram. Okay, free body diagram is a picture with a dot that represents the object. Then we start to apply the forces to it. Is there gravity? Yeah, the table is near the surface of the earth, so there is gravity. So the first force that we add there is going to be what we call the force of the weight. When the weight pushes down on this surface right there, the surface pushes back up. The other force, which is called the reaction force due to weight, is going to be called the normal force. Is there a force that is applied to the object? Yeah, that force is going to be called Fa, which we know is 600 newtons. And finally, there's going to be another force right here, which is going to be called the force of friction, which in number 2 is what we have to actually calculate. The force of friction in number 2, that's all in number 1 right here. That's the free body diagram here. Number 2 says to calculate the force of friction. I'm going to try and fit 2 and 3 on this section right here. The force of friction is equal to mu mg. The mu is given as 0.2. The mass is given as 45. G is given as 9.8. If I grab my calculator really fast right here and do that math, 0.2 times 45 times 9.8 is equal to 88 newtons. It's 88.2, but the force of friction is 88.2 or just 88 newtons. If I want to come back in over here and label it in over here, I can. It's just going to be 88 newtons there. These are not drawn to scale because FA is bigger than FF. It should be drawn longer. I'm going to go ahead and put the net force in right here. The net force, the next question, number 3, says that the net force, says to calculate the net force. Whoops. I lost my slide there. There we go. The net force will be equal to the applied force. Take away the force of friction. So that's going to equal 600. Subtract away 88. The net force is equal to, oops, you'll undo that. The net force equals 512 newtons when I do this math right there. All right, I want to try and squeeze to make things easier. I'm going to try and squeeze number 4 in right here, which says to determine the acceleration of the object. The acceleration of the object is equal to the net force over the mass. That's going to be equal to 512 over 45. 512 over 45 gives me an answer of about 11.4 meters per second squared. Oops. Right, you can pause your video and you can solve that problem right there. I'm going to pause and I want to set up the next problem that we're going to go over today. I'll be right back. All right, we're back with the next problem. The next problem says what we have is we have an object that's laying on the ground like this right here, or it's being pulled across the ground. And it's a mass of 55 kilograms. It says that the coefficient between the surfaces is 0.25, and then the applied force is going to be 700 newtons to it. That's 700. Sorry about that. Let's go ahead and draw a free body diagram, which is the first question right here. Free body diagram consists of the following. Once again, what we have is we have a dot that represents the object. The first force that we can look at will be is there gravity? Yes, it's near the surface of the earth. So it has weight. Just like the previous problem, I'm not going to change my color. We're going to see that the table pushes back up with what's called the normal force. We then have what we call the applied force. In this case, it's 700 newtons. Then we have opposite that what we call the force of friction. Wonderful. Let's go ahead and calculate that force of friction. The force of friction is equal to mu times m times j, which is equal to 0.25 times 55 times 9.8. That's 9.8. It's not my best 9.8. 0.25 times 55 times 9.8 be equal to about 135 newtons. It's actually 134.75. It's equal to 135 newtons. I'm going to check my math there. 0.25 times 55 times 9.8. Sure enough, I was right, 135 newtons. To calculate the net force, we're going to do our applied force, subtract away the force of friction, which is equal to 700, take away 135, 700, subtract away 135, gives me an answer of about 565 newtons. So that's the applied force. I'm sorry, the net force, because I have friction pulling back this way at 135, but the applied force pulling forward at 700. There's going to be a net force there. The applied force is going to win by the difference, which in this case 565. It's important to acknowledge that the force of normal force and the weight are equal and opposite to each other, so they have somewhat of they don't have somewhat, they have a canceling effect on each other. The final step is the acceleration is equal to the net force over the mass, so that's 565 over 55. It's about, the acceleration then is about 10 meters per second squared. All right, so I've done a lot of these problems here. I hope that you're taking time to practice them. I've done the multiple choice. So what we need to do is we need to go ahead. We need to take the test on Thursday. Okay, this is an important test. It's a unit test. Let's just figure it out, get it done, and have it done before the winter break. All right. So if you have any questions, please feel free to reach out to me via Teams. Thank you very much. Bye.